Alice, Bob, and Eve explain circuit knitting.
As much as I like knitting, this scarf is getting too big to handle on one set of needles. I wish I could break it into smaller pieces and then join them back together.
That's actually a great analogy for a technique in quantum computing called circuit knitting.
Circuit knitting is fascinating. It's an approach to running large quantum algorithms on smaller quantum computers by breaking them into manageable pieces.
How does my knitting dilemma relate to quantum computing?
Just like your scarf is too large for your needles, many quantum algorithms require more qubits than current quantum computers have available. Circuit knitting lets us divide these large circuits into smaller subcircuits.
Imagine you could be using two sets of needles to work on different parts of your scarf separately and then connecting the pieces.
But how do you make sure the patterns match up when you join them?
That's the challenging part. In quantum circuit knitting, we need to carefully track how information flows between the sub-circuits. One approach is called cut and stitch, where we identify places to cut the circuit and replace them with classical channels.
It's like cutting your yarn here, but keeping track of exactly how the stitches were arranged so you can properly join them later.
Wouldn't you lose the quantum properties when you cut the circuit?
Yes, there's a trade-off. When we replace quantum connections with classical ones, we lose some quantum advantages like entanglement across those boundaries. But the technique still allows us to tackle problems that would otherwise be too large.
Another approach is entanglement forging, where we use classical computation to approximate the entanglement between subcircuits.
How do you know where to cut the circuit?
That's part of the art of circuit knitting. We look for places where the quantum connections are minimal or where the impact of classical approximation would be smallest.
It's like identifying parts of your pattern that don't interact much with other sections. Those make good cutting points.
So this helps run algorithms on today's limited quantum computers?
Exactly. Instead of waiting for larger quantum computers, circuit knitting lets us use what we have now for bigger problems. IBM and other research groups are actively developing these techniques.
The beauty is that as quantum computers grow, we can reduce the number of cuts needed. Eventually, when quantum computers are large enough, we might not need circuit knitting at all.
So my knitting challenge is like what quantum scientists face: figuring out how to work with limited resources by splitting big problems into manageable pieces while preserving as much of the original pattern as possible.
That's a perfect analogy. And just like an experienced knitter knows where to divide a complex pattern, quantum algorithm designers are developing strategies for effective circuit knitting to make the most of our current quantum hardware.